what we've been doing has been leading up to where we can work with rationalizing the denominator. So yesterday, we worked on identifying the conjugate pair and multiplying by it. We are going to use that to help rationalize a denominator that is a binomial. That means there's two terms in the denominator. So we're going to be using those conjugate pairs today. To help with this process. And just like when we rationalize with a monomial in the denominator, we have to multiply by a 1. And so the numerator and denominator are going to be the same. For your homework, all of the ones that have the square roots of like square root of 5, square root of 7, so forth, they're only going to have a monomial on top. The ones that have imaginary numbers, they will have binomials or monomials. That means they could have one or two terms. So let's look at the first problem. If I have 7 divided by 2 minus the square root of 3, and I want to take and simplify it, get rid of the square root in the denominator, that means I need to rationalize that denominator. So I need to get rid of it. These square roots down there, so I need to multiply by the conjugate. So the conjugate of this is 2 plus the square root of 3. It needs to be a 1, so it needs to match the numerator and denominator that we're multiplying by. So when you multiply it, your numerator is going to be 7 times 2 plus the square root of 3. And the reason we spent time yesterday working on what the denominator will look like when we multiply by conjugates is so that you can practice with it and not have to write every single step. So if you were not here yesterday, you might go back and look at those notes and make sure you do that assignment first before you do today's assignment. So you have 2 squared. It's always going to be a subtraction sign between them when you're multiplying by conjugates. And then you're going to square the last. In the numerator, you can go ahead and distribute, or you can leave it factored. Some people like to reduce from the factored form better. And if you reduce from the factored form, you would look for what could reduce to that 7. If I distribute it, it will look like this. So either way is acceptable. And our denominator is going to be 4. This is always a minus sign here when we're multiplying by conjugates. Minus, what is the square root of 3 squared?
3.
Just 3. And so 14 plus 7 on the square root of 3 divided by 1. Do I need to write it as divided by 1?
No.
And so we have 14 plus 7 on the square root of 3 as my answer. If you would have left it factored, it would have looked something like this. And I would have accepted that answer as well. So let's work with imaginary. When you're working with imaginary, you're still multiplying by the conjugate of the denominator. So what is our conjugate of our denominator?
7 plus 8i.
And that gives me in the numerator negative 4 times 7 plus 8i. And my denominator, 7 squared minus 8i squared. Numerator, we end up with negative 28 plus 32i. Or plus a negative 32i, which is going to make that a negative 32i, minus 32i. 7 squared is 49. Minus 8 squared, 64. I squared is I squared. This I squared will, every single time, change the sign in front of it. So that square root, the I squared creates a negative. What that does is change the sign in front of it. So anytime you have that I squared, the sign in front of it is going to change. Whatever it is, it's going to become opposite. If you haven't figured out that pattern. So that makes this, when that I squared goes away, this a plus 64. So 49 plus 64 is what number?
113.
I'm going to go through some tricks for checking for divisibility. So 113, the last two digits, do they end in 13? Is it divisible by 4?
Sorry to interrupt.
So is 13 divisible by 4? No. It's not divisible by 4. Other things that you can trick, if you did not know this, and this is something I didn't realize a lot of y'all didn't know, if you add up the digits, so 1 plus 1 plus 3, what number is that? 5. If the number that you add up is divisible by 3, then that is divisible by 3. So those are two easy tricks. We all know that even means it's divisible by 2. But there's for 2, 3, and 4. And so when you're looking for checking for what will be the factors, that will help you see if anything can reduce. I know 28 is made up of 4 and 7, 4 and 8. And that means that 4 is a common factor in the numerator, but it doesn't work in the denominator, so we can stop here. So we're done at that point. But I just wanted to teach you some quick tricks, especially when you end up with the big denominators, to check for. The other thing, especially those that are looking at going up to college algebra, they will often ask for this to be in the form of A plus BI. All that means is they want you to write it this way. Separate out the two fractions. That's when they ask for A plus BI. Now, I told you on the imaginary, I am going to give you some where the numerator is not a monomial. Here's an example where it's not. So what are we going to be finding multiplying by? The conjugate of the denominator or the numerator? Denominator, because we've been doing that every single time. We're trying to get rid of the square roots in that denominator. And so we're multiplying by that conjugate of the denominator. So that's going to be 4 minus 5i. And it has to be a 1 we're multiplying by. So that's going to be the same in the top and the bottom. Now, the bottom, we've been working with these. They're the exact same. All that's different is the sign in between the two terms. So that means that this is the conjugate pair. So it works with that rule of squaring that first term minus the square of the second. Does the numerator fit that rule? No. That means we have to go back to what we did last week where we multiplied. And you can either use FOIL or the box method. 2 minus 3i and 4 minus 5i. And so 2 times 4 is an 8. That gives us the upper left-hand corner. Going down, 4 times a negative 3i gives us a negative 12i. Then we have 2 times a negative 5i gives us that negative 10i. And negative 3 times a negative 5 gives us 15, and then I squared. So that I squared makes this become
Negative 15.
negative 15. So let's look for our real parts. That's the 8 and that negative 15. So what's 8 plus a negative 15? Negative 7. Let's look at our imaginary parts. Negative 12i minus 10i. Okay, now let's simplify our denominator. 4 squared is minus 5 squared. The I squared makes the sign change. And so this becomes a plus. So 16 plus 25 is what?
41.
How much?
41.
41. We're done unless the problem, this is especially when you're looking with computer problems, they ask for in form of a plus b odd. That's when you separate into two fractions. This is the last new material for your test on Friday.